Today's engines are truly impressive, not just for their power, design, and eco-friendliness, but also for their unwavering focus on sustainability. These engines have the potential to transform the aviation industry and provide us with a glimpse of what the future holds. Modern airplanes are powered by gas turbine engines that compress and ignite air through multiple stages before expelling it. This process creates high-pressure exhaust, which drives the engine components and generates thrust. Every aircraft, particularly large commercial ones, requires substantial engine power for takeoff and flight. For example, a fully loaded Airbus A380 can weigh over 500 tons at takeoff. To support this weight, the aircraft is equipped with 4 powerful engines that together produce 150 tons of thrust. Each engine must generate enough speed to create the lift needed to counteract gravity and get the plane off the ground. The process by which the engine generates thrust can be broken down into 4 stages. First, the engine draws in a large amount of air through a fan and compressor. During takeoff, a typical commercial aircraft consumes about 1.2 tons of air per second. Next, the compressor increases the air pressure and sends it into the combustion chamber. Inside the combustion chamber, fuel is mixed with the compressed air, causing an explosion that creates the expansion needed to push the air toward the turbine. Once all these stages are functioning properly, the engine reaches its final stage, expelling air and fuel through the exhaust nozzle to generate thrust. Over the years, many engines have been developed using this design, but some have proven to be far more efficient and powerful, generating greater thrust. With the integration of advanced technologies, these engines have revolutionized the aviation industry. For airlines, having an engine that is both powerful and fuel-efficient is crucial, as it allows airplanes to cover longer distances while consuming less fuel. The current leader in the engine industry is the General Electric GE9X. If you're involved in aviation, you're likely familiar with General Electric's significant role in aircraft engine manufacturing, and the GE9X is no exception. While it has not yet entered commercial service, it is expected to power the newest member of the Boeing fleet, the Boeing 777X. Based on the previous GE90 engine, which powered older 777 models, the GE9X offers significantly more power, delivering a maximum thrust of 134,300 pounds, 5% more than the GE90 115B. General Electric claims that the GE9X is the most fuel-efficient engine ever made, producing fewer NOx emissions than any other engine. Thanks to the use of composite carbon fiber materials, the GE9X is 10% more fuel-efficient than its predecessor, all without a major increase in size. Set to debut in 2024, the GE9X will pair with the 777X, promising an aircraft of unmatched power and performance. Rolls-Royce is another leading company that has demonstrated its expertise in aircraft engine technology. When the U.S. Air Force decided to replace the aging engines in its B-52H Stratofortress fleet, Rolls-Royce saw an opportunity and designed an engine capable of enhancing the B-52's performance. The Rolls-Royce F130 turbofan engine, developed in a twin-pod configuration, is set to replace the TF-33 engines currently powering the B-52 fleet. These engines have already been installed on the aircraft, and testing is underway. Initial tests have reportedly yielded promising results. Before installing the F130 on the B-52, Rolls-Royce conducted extensive tests on the twin-pod design, confirming it was an ideal fit for the fleet's requirements. The company invested over 50,000 hours of digital engineering to further develop and perfect the B-52 engine, and it appears their efforts have paid off. The F130 can generate 17,000 pounds of thrust and is a variant of the BR-725 commercial engine. In 2021, Rolls-Royce signed a contract to supply over 600 new F130 engines to replace the B-52 fleet's aging engines. Although testing is still ongoing, the company is optimistic about the results. Soon, every B-52 aircraft will be equipped with these engines, enabling them to perform at their full potential. Pratt and Whitney is best known for its PW1000G engine, which powers the Airbus A220 and A320neo. However, the company has developed 6 variants of this engine, collectively known as the GTF Geared Turbofan family. Today, GTF engines power over 1,000 aircraft and offer unmatched speed and power. Pratt and Whitney claims to have invested $10 billion in perfecting this technology to make it the best on the market. What sets these engines apart is the slower speed at which their fans operate compared to the compressor and turbine, resulting in the highest bypass ratio in the industry at 12:1. This design contributes to improved fuel efficiency, reduced noise, and lower emissions. The GTF family is constantly updated with cutting-edge innovations to maximize power and performance. Each engine in this family generates between 15,000 and 34,000 pounds of thrust. Pratt and Whitney believes there is still room for improvement, but given the impressive performance of the PW1000G, the future versions of this engine are expected to be even more powerful, efficient, and quieter, incorporating the latest technologies to enhance their capabilities. A new addition to the world of aircraft engines is the Rolls-Royce UltraFan, the largest aircraft engine in the world. While the engine is fully operational and ready for testing, Rolls-Royce states that it will be deployed in aircraft developed in the 2030s. The UltraFan will be the first engine of the Vengeance family, with thrust ratings ranging from 25,000 to 110,000 pounds. This enormous engine is expected to offer a 25% improvement in efficiency. With a fan diameter of 3.56 meters, it is about 5% larger than the fan on the G9X. Currently, no other turbofan engine surpasses the UltraFan in size. The UltraFan features a planetary power gearbox between the fan and compressors at the rear, allowing the fan to operate at an optimal low speed while the compressors run at an optimal high speed. In early tests, the gearbox operated at 87,000 horsepower, setting a new aerospace record. Engineers have designed the engine to circulate large volumes of air around the compressor core and expel it directly behind the engine, helping to reduce noise by an impressive 35% and significantly boosting fuel efficiency. CFM International, renowned for its CFM 56 engine, once considered the dominant narrow-body engine of the future, has now taken things a step further with an even more groundbreaking innovation. In 2021, the company introduced the RISE program, revolutionary innovation for sustainable engines. This initiative aims to develop the next-generation CFM engine by the mid-2030s. Currently, CFM is focused on creating an open-rotor engine, which is poised to revolutionize aviation technology. While this engine may not be ready for several years, CFM International asserts that it could reduce fuel consumption by up to 20%. The engine will incorporate advanced technologies, including composite fan blades, heat-resistant metal alloys, hybrid electrical systems, and additive manufacturing processes. The RISE program involves over 300 components, modules, and complete engine builds. Once available, the engine will be compatible with both Boeing and Airbus aircraft, marking a significant milestone in the evolution of aviation. While the future of the RISE engine remains uncertain, its potential certainly looks promising. Although it is a new model yet to be released, it deserves recognition as one of the most powerful engines in the world. Another standout engine is the Rolls-Royce Trent XWB. which powers the Airbus A350 and comes in two variants, the XWB-84 and the more powerful XWB-97. The XWB-97 boasts a maximum thrust of 97,000 pounds, making it one of the most powerful and efficient engines ever created. It has enabled the A350 to usher in a new era of ultra-long-haul flights. The XWB engines are equipped with a two-stage intermediate pressure IP turbine, replacing the single-stage turbine used in previous Trent models. Although exclusive to the A350, these engines can be adapted for use in other wide-body aircraft. The XWB engines have proven capable of supporting both short flights as brief as 45 minutes and long-haul flights lasting up to 16 hours, offering unmatched reliability and versatility. With the tremendous success of the XWB family, Rolls-Royce is moving closer to developing an engine that will truly revolutionize the aviation industry.